All right, we're going to start. Thank you all for coming to this breakout session. I am Chaco Daniel. I am a Principal Program Manager with the Hyperscale Compute team in Azure. This is my colleague, Kunaldeep Singh.
Hey.
He also works with me with the same team. He's going to be co-presenting with me. So in this session, we'll walk through the various Service Fabric capabilities that will help you deploy, monitor, troubleshoot, diagnose, fix issues in a distributed application at scale. In the past, for example, the maintenance windows were actually a given. So given the fact that we live in a world at this point where customers and business expects the service to be up and running 24/7, 365 days a year, there isn't an opportunity to take a maintenance window. And in between, the expectation also remains that we actually have to also improve the service and add new features, etc. So as developers and IT pros, the need and the ability to manage and monitor and diagnose your services and fix issues in real time is actually a priority one. And also performing upgrades without downtime is actually key to any mission critical service. So the architecture which you put in place on day one should work even the fifth year going, and it should be able to scale out, scale up, and so forth. So this means that you're thinking about service delivery, about availability, about data integrity, and rolling upgrades and scalability. Let me show you how Microsoft Azure Service Fabric allows you to do this very easily. So in this whole talk, we'll spend 50% of time on demos, and the rest of them would be on just the deck and explaining concepts. So let me just quickly give you an overview of what this platform is. So this, I'm sure if people have attended the other sessions, have seen this particular slide before. So I'll just make it very quick in here. So Microsoft Azure Service Fabric has been a key ingredient in taking tier one products like SQL, System Center, Link, and transforming them into running as cloud services. So this particular platform allows you to build scalable and reliable services very easily, allows you to keep compute and associated state together to achieve high throughput and low latency, allows you to manage full application lifecycle, deploy, scale, monitor, troubleshoot, upgrade applications easily with no downtime. The code you develop and test on your development environment is the one which you deploy on your production environments, and that's something which this particular platform allows you to do, even without any changes. And this, of course, it also says that you can deploy that to on-prem or to the cloud or any other platform which runs Windows at this point. So, for example, our platform, SQL Azure, is one of the largest and complex users of the application lifecycle management features of Service Fabric. They regularly kick off close to 40,000 application upgrades on each of their clusters worldwide, and the platform handles it without any issues. So you're getting a platform that is tested to its seams almost every day. So anyway, that's the overall introduction to the platform itself. So now we can actually dive deep into the management capabilities. So one of the key things I want to start asking you questions on, and then it'll be a good way to go through all these capabilities. Per one of the studies, based on some industry surveys, the cost of downtime actually is around $300,000 per hour on an average. This means that you have no option but to keep the service up and running 24/7, 365 days a year. So for this, what do you need? You need reliable optics into what's going on with your service at all times. You need to know if some partitions are running hot. Do you need to scale out your environment? Do you need to scale up your application? And of course, you certainly don't want to be woken up at night just to add some capacity to your environment. So that you expect the system to take care of it for you. And well, you may even want to expect the platform to also do some self-healing and repairs based on the policies you set. You might just choose to say, okay, if the first time my application dies, restart it for me. And if it still dies, you can always say, I'll escalate my policies to say, reboot my OS. And then if that is not working, why don't you reimage the OS? And then if even that doesn't work, then call me. So by the time you get called, the platform has already done all these things for you, so that you are now into the real problems and not trying to figure out where things are. So then the other thing is, what's interesting about this one is, if you want your service to be up all the time, you also make sure that you don't want to be called for issues which are truly not issues. So when the last time a lifeside incident happened, say for example, how easy was it to figure out what was wrong? We truly need a platform that makes testing in production less stressful. So how easy was it to deploy a fix confidently into production without being worried about it, wondering whether you messed up some configuration? Have you deployed the right version into production? Given the pace of business, you are not allowed to relax just because the system is running smoothly. You're expected not only to keep it running smoothly, but also make sure the features are added without downtime. Microsoft Azure Fabric allows you to do all these with ease. So I'll go into some more details on each of these concepts throughout this session. Let me get a few concepts and keywords out of the way at this point. Okay. So the very first term which we have is the Service Fabric cluster. It's actually a set of machines, physical or virtual. The Service Fabric stitches together to form a reliable and a fault-tolerant unit. Service Fabric actually is topology aware, so it uses that information to make some placement decisions. Service Fabric clusters certainly can be scaled to thousands of machines. When setting up your cluster, you actually can decide and specify as to what kind of failures your cluster should survive. For example, you can choose to set up a cluster that spans 3 Azure data centers so that the cluster can survive a loss of a data center. So one good example which we like to quote is the Bing Cortana service which we own, which actually runs on a cluster that spans three regions, making it tolerant for regional failures. Like for example, last year they had a widespread outage, which one of their data centers just was lost, and those machines were lost. And basically, what happened is that third of their capacity went down, but the service suffered no disruption. The service just failed over real time to the other 2 data centers in other regions, and that's kind of reliability you can get with Service Fabric. So I'll talk about what are the other considerations you need to think about when you think about a production cluster later in the session. So in this particular diagram, if you really look at it, I have little semicircles drawn, just basically indicating that these actually depict the fault domains and where these machines are kept. This basically is a 6-node cluster. So there has 3 fault domains, and then I have 6 upgrade domains. Upgrade domains are basically a logical unit which allows you to specify as to how many machines should go down at any given point for an upgrade. That's all it specifies. So these are things which are knobs which you can specify while you deploy a cluster. So now let's talk about applications and services. So Azure Service Fabric supports creation of both stateless and stateful applications. And so what does this services contain? So each of these service contains code and an associated configurations to form a service package. And each of the service package defines the service type and actually is the unit of deployment and activation. So the way to think about a service package is it typically performs a standalone function. It can start and run independently. That's the way you would define a service package. The reason why you want to define it in such a way that you actually should be able to upgrade or change a config. You should be able to delete a service package without affecting the application itself. That's the way you should think about it. So then let's now think about what an application package contains. An application package contains one or more service packages and defines the application type. So what is an application type? It actually is a unit of lifetime versioning and isolation. For us, basically, this is the unit of isolation. That's how you should think about it. The service package was a unit of deployment and activation. This is the versioning and isolation unit. So you might think, Yeah, so of course you can have more than one service packages in an application. So you might be wondering, how do you decide whether now I should have a service package instance made or an application package instance made? So that's something which is totally up to the business. It depends on what kinds of guarantees do you need. Are you looking to do, do you need isolation or not? So that's the key here. So let me go to the next step. So yeah, here. So now I'm ready to instantiate one of the applications. I have an app which is called app4. It has a version 1.000, and it has two service packages, a red hexagon and a yellow hexagon. So I've decided that it needs, now I'm going to instantiate these. I need 3 replicas of each, and basically 1 primary and 2 secondaries. So basically, and then you make a call. So basically what happens is the system decides where to place them. So if you look at the placements, it actually is unique. To give you reliability, it actually has figured out placements in such a way that you have FDUD uniqueness here. So that is the key here. So doing an upgrade, you still don't lose more than a quorum and so forth. So we actually will go over the application scale up and partitioning later in the talk. So let me just show you how it's done at this point. Let me give you a demo. Move. Okay. All right. So let me just do a demo. Let me switch this to. Okay, so I'll do a couple of things here. One, basically, let me go and create a cluster. That's something which I want to show you. So instead of creating a cluster using PowerShell, what I'll do is basically show you a preview of the portal. Certainly at this point, the portal is not available for you guys to use, but it'll be available like sometime later this year. So it is actually on Ibiza portal like the other ones. So compute. Quickly go through the thing. Service Fabric cluster, create. So this blade basically comes up. You can just say this would be so this would be associated with a resource group. I'm sure you guys know what a resource group is. Basically, like all other concepts in Ibiza or our portal, you expect all the resources to be associated with a resource group. So you're going to create a new resource group here. You can name it the way you want it. So I'm just going to name it the same so that it's helpful for me to remember. The subscription basically is, okay, then it's done. Location, let me choose Southeast Asia for now. And then in terms of what's the kind of machines do I need to have for my clusters? At this point, okay, so now you can just choose. There's a big list here. You can choose any which makes sense to you. For me, it's defaulted to D4. I'm good. Number of VMs you need in this cluster, you can choose. When we come to preview, this actually will be a list which will be like you can do 6, 7, 8, 9, whatever. At this point, I just have 5, 10, and 15. So let me just do 10. Since this particular cluster would be using IaaS VMs, you are expected to select a RDP password. And so this is what I'm taking in at this point. And then there are a few other concepts here, which is interesting. So one, basically, Service Fabric will cover security later on, but basically it expects that a cluster in production at least has to be secure. And we give you, one of the ways you do is basically use a certificate, a X591 certificate. You can actually upload the certificate into the key management store which you own and give the source vault name and its path to the URL to that certificate. And we'll take care of making sure that your cluster is secure. And then if there are any other specific things you need for your application, you actually can give it here. Okay. So of course, now it has mandatory. So for this particular demo, I'll just make sure it's none, and go on. Then there is the service fabric configuration. This is actually one of the ways where you can actually tell the cluster that, okay, I need you to open certain ports for me, because I expect to be open to the public from these particular ports. So you can actually say, you can just basically give 80, 81, whatever. So basically that will open the HTTP ports for you at that point. And then all you're doing is create. So I have this thing, so it's going to get created. It's going to take maybe 5 or 10 minutes based on different factors. So let me just take one which I already have. Let me browse to one of these very quickly. So I have one here. Okay, let me just pick up this. So this was the build one. Okay, let's take this one. Okay. So this pane basically said, give me all the resources which of type cluster, and then here's a list of them which under my subscription. I chose one of them, so it comes here. So let me just open up this Essentials tab out here. This basically gives you at a glance as to what's your address of your cluster. How do you get at it? So the public IP address for this particular cluster is this. So that's the address, and then you use 19,000 to connect to it. And then if you're using REST, then you use that. So okay, maybe there's a good time to introduce you to some amount of health reporting which we do for you by default. So there are different kinds of entities which we have. We talked about nodes. So certainly our health reports are available to you at the node level. There are 3 things which are very key here. The health states of error. Certainly there is something wrong with the node. We can't reach it. There is something going on. Then basically that's the one which will get flagged, and it will have a number of nodes here. And then OK, and then warning. Unknown comes in only very shortly sometimes when a brand new node is trying to join the federation and we don't know it. So at that point there is actually no report on it, and then you just get this unknown. Otherwise, typically you should not be able to see this. So when you click on it, you can drill down. Basically, it just gives you this is a 9-node cluster, and all the health states are okay. And then see here it says this is in fault domain 0, 1, 0, 1. So these are actually split into 3 fault domains. So this particular cluster by default will be on 3 Azure fault domains. And then you also end up getting 5 upgrade domains. So now let me just quickly look at the applications. So we talked about the node as an entity. So the next level is if there are applications in your cluster, and in my case I have 4 applications I have already deployed. So it's actually now reporting health on the application. So what's interesting about this one is as a DevOps person, typically you don't go and look at OK things. You'll typically go and look at what's an error or warning. So in this scenario, by God's grace, I have everything okay. So, but I'll just show you this. But typically you would be going in only if there is a real need for it. So here it is. Okay, so I have these four applications running, and they're all in OK state. Let's just go into, so now you got the health state of the application itself. So now you can let's go into one of them. Let's go into the Chaos app. So now we are actually on the application dashboard. It again talks about what its type is, and then what's the name for it, and gives you all the details here. Then it talks about, okay, I have 2 services, service packages running in it. So there are 2 service instances in it. Then you drill down into it. So now you got health at the service level now, and then you basically go down all the way up to the partition and the replicas. I'll just make it very quick out here so that you can see it. So in this thing, I have a stateful service and a stateless service. Let's go to a stateful one, and basically it says it has 1 partition, and partition is healthy, and then here's my replica. So basically in one or a few clicks, you actually are all the way down into the replica at this point. So let me recap a little bit for you. So basically, the health is at the 5 levels I just talked about. It actually gives you at the node level, application, service, partition, replica, and then the cluster itself is there. So basically now we have a cluster. So now let me introduce you to another tool which is in your SDK. This actually is called the Service Fabric Explorer. So I have actually links to it. So this one basically this is the cluster we saw on the portal. So it just says all my system services are healthy. It has these applications loaded already. Okay, and then you can just look at it this way. So I will use this a lot. So let me just now do one thing. So now let me deploy to this cluster using PowerShell. So I'm connecting to my cluster. So you could have used Visual Studio as well to go connect and do all these things. I'm just showing you a PowerShell version of it. So the PowerShell comes with your thing. So I've already registered. So there are 3 steps for any applications to be deployed. One, basically you copy your package into the cluster. So I've done that already. When I do an upgrade, I'll show you that it's copied, and then I tell the cluster or tell the system that yes, now register this application type for me, and then I will say, can you just create an instance for me? So now it will create an instance for me. So now if you see this particular Visual Objects application which I had, so now it says, yes, I have it, and it's running. So let me give you a quick overview of what I just did and what this particular Visual Objects demo is all about. So this basically has 2 services. There's a Visual Objects service, and then there is a web service. There it is. So, and on its version 1 of code and config, and I have deployed it. So let's just go look at it at this point. Okay, there it is. So I have all these visual objects or pyramids which are jumping back and forth. So during this session, what I will also do is I will upgrade this so that real time you should be able to see that these pyramids start to rotate. And then there's a tail on these pyramids. Basically just says that where this is the position of where it was at like the previous maybe 10 positions. That's what the tail is. So the key is you shouldn't be losing any of its tail, and it should not forget the last position, even when I upgrade. That's the key here. So we'll do that. So let me quickly do a little zoom here. Okay, that's better. All right, so I'll go do the upgrade shortly. Let me just switch back to the PowerPoint a bit, and then talk about the no downtime upgrade at this point. And then I'll come back. So upgrading services with no downtime. So basically what in this particular PowerPoint, what I've done is basically replace the yellow hexagon with a green hexagon, and that is the only change I've made. So basically I expect System Fabric to just replace those even if I submit the whole package to it. So that's the key here. So upgrade can be kicked off using PowerShell or an API with the Service Fabric provides. Upgrades progresses 1 UD at a time. That's the key. So at this point, what happens behind the scene is basically there is another primary elected, and then the particular replica gets upgraded. That's what really happens. So we perform health checks at the beginning of every upgrade and end of every upgrade domain. So you can choose to specify health policies at 2 levels. One is at the cluster level. So at the cluster level, you can say that I want to make sure that only 2 nodes are down from, say this of the 6. So you can specify that. It's basically a percentage which you say 10% of my nodes can be down at any given point. I have enough of headroom, so 10% is okay. And so the cluster is still healthy. Then the other thing which you also specify is the application health policy. And there you say, okay, either you can choose to say I can have a downtime. In certain scenarios, like you're testing something out, you're okay. In production, of course, yours will be a 0. So 0% will be considered healthy. So the system actually takes care of that while it's actually navigating from UD to UD. So that's what it does. And So there's also another mode which you can specify. You can either say automatically roll back if the health policies are not met, or you can say, okay, pause, and then I will attach a debugger, figure out what the heck happened, and then I'll call another API to say, okay, proceed further, or roll back. So these are all options that you have. And so as a cluster owner, you can certainly define very global policies, which certainly can be overridden by with every call you make for application upgrade. So a certain application can choose to have a different health policy than something else. So those kind of flexibilities are there. Okay, now let me just show you the no downtime upgrade. All right, so I'm back here. So these things are running. So let me make a small change. The only change I want to do here basically is this particular state.mode, make it true, right? And then that's the only change I'm making. Basically, this change is just made to the visual object service. The web service piece I'm not touching at this point. Let me compile. Let me package. So now it's packaged. Okay. So let me just go to that particular folder and then show you a few things. So this is how the package layout is. So let's just go into the package. It says release. So you see there is an application manifest here, and then there are two packages the Visual Studio put. So in this scenario, all I changed was basically the visual objects one. So let me just delete this package because I don't need it. So I'm going to give it a very small package at this point because that's the only thing I've changed. So I go into the service manifest. This actually defines basically that particular service type. So let me just go in quickly in here. Let me just close all these things here. So code, I made a code change. I just change it to 2, and then also change the service type version. So one of those things which you may be wondering by now is there a very fixed version schema. So version schema itself is something which you determine. We ourselves do not care as to what kind of names you can call it, apple.orange.com or something, whatever makes sense to you. It doesn't matter. So this is not something which we use internally. This is something which allows you to keep track of your configuration. So now I've made that change. Now let me go back and then make a similar change to my app manifest because that is the one which defines the application type. So in this, the only thing which I changed was here. So I'm just going to make this change here, and then also update my application type. Save it. So now my package is ready. So now let me now take that package. Copy the package over to the cluster. So basically, when you copy, all you're trying to do is indicate to the cluster that copy it into its image store. That's what it's trying to do. And the image store is actually a system service which is available for you. Register it, and then we'll start our upgrade. So this is another just a simple command: start fabric upgrade. The application upgrade, and it just says type 2. Go and do it. So at this point, it started. So let's just go back to this thing. So let's refresh. So it says, see, it's now it's going UD. There are 5 UDs. The very first one is started to upgrade. Let me just keep it on refresh for a second. And let's see what's happening with our bouncing fellows here. So here there is one guy who paused, and see now it's actually started to rotate. So without any downtime, basically, so you have rotations in this now. So, and as it completes, you will see this going on. So we'll let it go on, and I can certainly leave it. So it's going to go on for some time, and you'll see it proceed UD by UD, checking the health while it's going. So what's interesting about this is, although there is a little pause, there was no state lost, and you just continue where you are. So that's the key here. Okay, let me go back to my PowerPoint, and we'll let it go on, and then we'll come back to it. We'll see that it's completed. Okay. So now that you have your application, and now let's talk about the fact that what does it take to define and be ready for deploying into production. So with confidence, that's the key. So the very first one, let's just talk about the security and compliance topic. So security was built ground up into the platform. We support role-based access control. You can use certificates. You can use Active Directory, Azure AD to secure application and cluster. All the system logs and events are logged, so for compliance reasons. Application logs and traces can be retained per whatever policies which you guys want to define in terms of retention. Application scale-up. That's the other thing which I had pointed out earlier. The application which you deploy or the architecture which you use of day one should be able to sustain you even on like year 5. So that's something which we allow. So when you're actually a small startup or testing a market, you have a strong need to be able to offer services at minimal expense, but the ability to scale out. So what we allow basically is allow your applications to be partitioned. We allow you can choose a very large partition size, for example. You could just do a minus N64 plus N64. It's the largest thing you can think about. And then System Fabric will auto-scale the VMs as needed to do the resource balancing for you. So you're not worried about it. So certainly you specify as to what are the parameters of auto-scaling. But other than that, we do it for you when certain criteria are hit. Application reliability. What kind of failures do you want to survive? What's your SLA? How many replicas do you want your service to be running at? These are the things which you have to consider when you think about application reliability. And you actually can choose all these parameters when you are deploying your application. So whatever you deployed on your laptop is not what you think in terms of when you deploy it to production. So you can actually simply change the configs. I just showed you the application manifest and the service manifest. You can change it. You can change things at deployment. So that's the key here. So then the next thing which I've mentioned is testability service. Yes, no one wants to test the limits of their system in production. Customers' data and your SLAs at risk. So Service Fabric provides an inbuilt service available for you to use. This service simulates the real-world failures in your cluster and puts it through its paces. Since the service is also integrated with the health subsystem, it will actually pause the test if the application fails. So basically, it also uses your own health policies to figure out, okay, now it looks like your application just went unhealthy. Now it's time to attach a debugger, figure out what the hell happened there, and fix it. So that's the key here. So generally, the faults which you see in months or years, you can simulate in hours by using this particular testability service. So in some of our customers, this particular service is so popular, they have it running in production so that they actually can figure out a problem before years come by. So, and then the last topic, that is the health monitoring and diagnostics. So that will be covered by Kunal later once I'm finished with my demo. Let me just show you the demo of two things. One, where is it? Okay, there. One would be the resource balancing, which we just talked about. So basically, the Service Fabric accommodating the addition or deletion of machines to the cluster. And then the second one basically is the testability service itself. So we call it the chaos service, but as very dearly. So anyway, let's just go into this and show this. Two. So yep, it looks like all of them have converted over. So let me just quickly go into, let me go here, and then show you a couple of other interesting things you can do here. So here I showed you the application view out here. And then before I go there, let me introduce you to another viewer I have. So this actually is nothing but a simple view of what this cluster has. So anything which is, let me just zoom in a little bit. So anything which is dark is actually just an active secondary, and anything which is like this shiny things are actually the primaries. Okay, so let me just keep it here for a moment. So we'll watch this when I get a node down. So you can certainly go to this view and then say, for example, let me see what would be interesting. So let me just take down the number 3. Right click on it, activate, deactivate, restart. So basically just saying, so what happens here is interesting. You'll just see that particular machine, basically this is simulating a condition where suddenly you lost machine 3. So basically you would see that all the replicas on that starts to get moved, and new replicas start getting built, and see that's gone. So this is something which our system already does automatically for you. Okay. So now let's introduce the other fun thing which we're talking about. So here's the chaos service, which we call it chaos service, and so it has a nice UI, which is very colorful. So let's start the faults. So at this point, it's running some faults. So the very first thing it did was check for the healthiness. And then it says, okay, now I'm going to restart my replicas at this point. And then it just goes on. So you would see this happening here. So I'll let this run, and then you should see these things go back and forth on this one. So you say this is like, it actually did a package restart, and then it checked for health. So you'd see things are moving. It's doing its test. And then all the while, this guy who was running on that cluster is still behaving just fine. Okay, so the reason why I got that fault is because it's from here, because I think something on this particular one basically was on node 3, and so it just got a warning. So it's not a very big deal. It continues on. Sorry, let me bring it back. All right, so let me just quickly go through a couple of other things. So while you were thinking about this one, is maybe you are thinking, okay, how easy or difficult is it to let our resource balancer know as to what kind of load am I consuming? I need to be moved off this particular node. So it's a very simple thing you can do. So let me just walk you through a manifest called cluster manifest. This actually describes the cluster itself. So all it's saying is basically for this node type, my capacity is 100. So this 100 is just something you randomly choose. You can just choose whatever you just have divided this node into 100 pieces. So that's all it is. So just telling the system that it actually has a capacity of 100, and then while it's running, you actually can report a load, saying, okay, this is just one line, it just says metric, and I'm going to report a load of 20. So basically, what it's indicating to the system is I can fit 5 of these into that node, and that's how you indicate to the system that, okay, here's the load I'm consuming. Say for example, after a while you figure out no, it has to be 30. You can change that at runtime, and then the system will do the right thing for you. It'll move it around. So basically, let me go back to my. So just for the heck of it, I have to show you that this is still running. Chaos is still happening. So it's just doing all the stuff by itself. So let me just go back to the PowerPoint and then talk to you a little bit about our orchestration engine. Just to recap what I just showed you of the capacity and the ability to report load, that actually, and then the fact that it can then our system service can actually react to any environment changes. So Service Fabric is a state-of-the-art container orchestration engine. It allows you to specify rules of placement, resource consumptions, node capacity, and update them in real time. That's the key here. You can adjust these on a running cluster, and the system will manage resource balancing for you. So this is something which is actively used in a lot of our tier 1 customers. So like, for example, SQL offers 3 kinds of databases, standard, free, and premium. They define the node capacity such that a premium database, when it reports a load, has a complete machine. So thereby making sure that the resource on that node is guaranteed for that premium database. So that's how they use it. Whereas if it's a standard or a free tier, they don't guarantee the resources for them, and so they pack as many they can. So these are things which you can use to your benefit in terms of how you would position your offering to the public. So now so let's just now go to the topic of monitoring and diagnostics. So let me turn to Kunal for it.
Thanks, Chaco. Hey, everyone. So as Chaco mentioned, I'll be talking to you guys about monitoring and diagnostics and how we are enabling you to do this with Azure Service Fabric. I know it's quite late in the day. Thanks for being here with us. So let's assume you've done all the things that Chaco just talked about, and you have your application and services running in production now. You want to have some kind of visibility into how your application and services are doing there. And for that, you need monitoring. So there are 3 different categories of monitoring scenarios that we are enabling for you in Azure Service Fabric. So first is performance monitoring. Then there's the health monitoring. And then ability for you to collect business telemetry. So for performance and stress response, what we are doing is we are outputting a rich collection of metrics from our system and our programming models so that you can understand how your code and logic is exercising the platform underneath you. We are also making it easy for you to add your own custom metrics from your application code so that you can understand how your business logic is performing in the real world. What are the slowest API calls that are happening? What are the spikes and surges that you're seeing? So that you can look into it and optimize your code further. We are also enabling health monitoring. Chaco already showed you some demos for this in the portal and with the Explorer tool. What we have for health monitoring is an extensible and flexible health management system, which right out of the box provides you rich data about what the health of the cluster and the system services is. And because it is extensible and flexible, you can add your own health reports to it and understand how your application health is doing. This is something that you can then add on with some real-time alerting so that when something goes wrong in production, you get a real-time alert on the failure so that you can quickly look into it and troubleshoot that. And then we have the business telemetry. I'm sure once you have your services running, the business manager comes in and he says, I want to know what our usage statistics look like. What are the page views? How many people are logging in? Where are they spending time? And the way we are building this system, it'll be easy for you to track those metrics and create reports and charts out of that. Let me give you a quick demo of our integration with application insights. So here we are on the Azure portal. Let's go and look up application insights here. This is a demo that we have set up for this session. And I have my favorites set up here. And then we have these demo charts. So this is a real cluster that is running and outputting metrics. And these are the system metrics that I was talking about. So this is an actor-based application. And the first chart that you see is the number of calls happening per method type for an actor over a 1-hour slice in the last 24 hours. The next one that you see here is the number of calls happening per actor ID. Again, it's 1-hour slices during the last 24 hours. And the next one here, this is the average request response time for different method calls, again, over 1 hour slices. So this kind of gives you an insight into what are your slowest method calls, and if these are not as to what you expected them to be, you can drill down, figure out what is the situation with the code in there, and then try to tweak that and see how the new code responds to it. And right at the bottom, we also have the load per node, because you might want to see if some nodes are more heavily loaded than the others, and then you might want to change your resource balancing matrix for that. All right, so I'm not going to give you a demo of the health tool because Chaco drilled quite deep into that with both the portal and the Fabric Explorer. So let's assume now you have this monitoring setup, you have the health monitoring, and then you have a real-time alert or a customer calls in and they tell you there's something wrong. In this kind of a situation, what you want to be able to do is quickly understand where the problem is, what the problem is, root cause analyze it, and be able to fix that. And we are ensuring that you have all the right tools to do that when you are running in production. So let's look at the things that we are doing here. So first of all, we are doing detailed system optics. Ours is a sophisticated system that you're running on, and you want to be able to know what was happening in the system at a given time when the fault occurred. So we are giving out repair suggestions, such as if there are callbacks from the system that you're handling, such as run async, which you use if you're using the reliable services programming model, then if the run async callback is running slow, or if there are failures in there, we report out events for that so that you can quickly know that there is something going wrong and go and fix that. And we are also logging all the important events that are happening in the system. Chaco just showed you how to deploy and create an application, how to upgrade that. And we are making sure that all of these events are being reported out. So every application creation, service registration, all the deploys and the upgrade and the rollbacks, all of them are getting logged. And then you can go and look those up. We're also enabling custom application tracing through ETW. ETW is an industry standard. It is fast, and it works across environments. So the application tracing code that you write for your local dev box continues to work when you take that application code and deploy that on production. No code changes required. And the way we have set these helper calls for you to report out events from your application code, make sure that all the right metadata is logged in there. Because this is a very complex distributed system underneath, and you want to be able to understand if there's a tracing call, where is that call coming from? Which node, which application, which service, which partition, which replica. And we make sure all that information goes with that event that you wanted to report out, so you know exactly where that event came from. And we are also making sure that there's a choice of tools that you can work with. So right out of the box, we have a Visual Studio Diagnostics Event Viewer. So when you're working on your local box, you can see all the ETW calls from the system and from your application code there. And then you can also use Windows Event Viewer. When you take and deploy this code to production on an Azure cluster, you'll be able to set up the Windows Azure Diagnostics extension and see all of these logs in operational insights. And at the same time, because we are using an industry standard in ETW, it makes it possible for you to use your own choice of tools, such as Kibana and Elasticsearch and more. And I'd love to hear from you what are the kind of tools that you guys are using so that we can make sure that it's easy for you to work with those tools when you're using our technology. At this point, let me give you a quick demo of the Visual Studio Diagnostics Viewer. So here I am in Visual Studio, and this is just a project that I created from the template. No code changes at all, and I press F5 here. So while this is deploying, let me show you some of the example code that we have here. So if you see this code here, This is an example of a call from your application code. This is a custom trace. And you are using a helper method that we provide in the templates here. So here's the diagnostic events viewer, and you can see there are messages coming out. Let me just pause this for a while so that we can look at some of these messages. So what we have here are the system messages. So this one says that the service got created. And right in the same mix, you can see messages coming out of your application code. So the code that I just showed you in your application source file, this is coming right out of there. And you can see it says the current counter value is 0. And right below that, in the payload, you can see the service name, the service type name, the replica. And all of this information was something that you did not have to add. Like the system automatically added this. So you know exactly in the real world where this message is coming from. So that's what we have. Let me switch back to the slides now. So let's assume the demo that I just showed you is what happens on a local dev box. Now assume that you are running this on the Azure cluster in production, and you have multiple nodes there. How can you go and see all of this data in one place? So this is how your flow is generally going to look like. You have your application and service code running there, and then you also have the service fabric runtime. And both of these are outputting events as ETW, which is being collected in the ETW subsystem in Windows, which then gets picked on by the Windows Azure Diagnostics extension that you can install on any VM in Azure. And all of these Windows Azure Diagnostic extensions running on each one of your nodes will put these logs and traces onto a common Azure table. And once they are in a common Azure table, you can just go to Operation Insights, where you have this Operation Insights resource group configured to look at that Azure table and show you all of these logs in one place. And because Operation Insights does indexing behind the scenes, so the searches over logs, even if they are big, are extremely fast. So let me show you a demo for that. So we already set up a cluster with Windows Azure Diagnostics enabled there and hooked up to Operational Insights. So this is the portal view of Microsoft Azure Operational Insights. And we have some queries here which you can use to search through the logs. So let's say you want to see all the application upgrade events. So all you need to do is run this query and show you all the events for the application upgrades. So if you choose one of these events, you can drill down into the details, and then you can see that it talks about application upgrade started and also tells you what application it was for. You can also customize your queries further. For example, say if you want to see the application upgrades for a specific application, so you can use a query which says, show me all the application upgrades for the visual objects application, and then it'll filter those out. And then you can also search for other things, such as, let's say you want to see what application upgrades got completed. You can search for those. And here you see all the application upgrade completed events. So that's it for monitoring and diagnostics. I'd love to hear more from you on the kind of things that you like to see enabled, or if there are things here that you like, but you would like to have them change a little bit. So I'm all ears. Thanks so much. Chaco, back to you.
All right, so let me recap as to what we just learned here. So Service Fabric management capabilities will enable you to run service without downtime 24/7, 365 days a year. It manages clusters, small and large, handles failures, machines, or applications automatically. It's unaffected by hardware, software, or communication failures. Makes application lifecycle management easy. It supports automatic rollbacks and upgrades. It gives you container orchestration. It gives you resource balancing, governance based on rules, ensures efficiency, performance, scale, density, resulting in better COGS. And best of all, it provides extensible health diagnostics and monitoring. So I have a few things for you to follow up. So one thing is certainly we want to hear from you. Please go download our SDK and learn and give us feedback. Attend the upcoming sessions. There are 2 of them. One basically it is the orchestration itself. It gets a deep dive into the orchestration engine itself. You can ask questions, very deep questions on it. The second one, which is at 5 p.m. tomorrow, is a deep dive into the actor programming model. So please do attend those and tweet, of course, good things about it with the Azure Service Fabric tag. And then thank you so much for the time. And please do evaluate us on this session. This evaluation is important to us. Now we'll take questions, please.
So I've got a couple of questions. One is when you've geo-replicated your nodes, how is there a way to put like traffic manager in front of it so that when a customer from a location near there will get that node rather than being pushed to say something at US West when they're coming from Australia or something like that?
So let me rephrase your question. All you're saying is I need to be able to affinitize certain primaries, certain replicas to say some regions.
Right.
Yes, that's possible.
Okay. And the other question was, I've lost it. I can't remember what it was.
We'll come to you.
Quick question. Is it possible to do A/B testing while rolling out new version of code?
So there are multiple ways of doing A/B testing. Answer is yes, of course. So one, certainly you can have multiple partitions in your application and just upgrade one of the partitions. That's one way. Second way is, and a better way would be to think in terms of application instances you create. And then so you can have multiple instances and you can say certain instance of your thing is always going to be some of your friends who will try it out first. And then there'll be other people who will be on other instances who would want more stable products. So in that way, you upgrade the whole app instance. You see how it's performing, and so it's not affecting anything else. So those are 2 ways of doing it. Yes.
Another question. That will be coming with Azure Stack, correct? Or
this is coming. This is actually possible in our SDK today. So go try it out.
okay.
Let me go back.
Yes. That's just the development environment. But if you want to run that in production on-prem, is it going to be just on Azure, or we can bring it with Azure Stack or Windows Azure Pack type of thing?
Yeah. So Azure Stack, when Azure Stack comes about, certainly you can take it on-prem. That's for sure.
Okay.
And then, as of today, basically you have your laptops or your machines. You can set it up. It's on-prem.
Okay.
Right. So you certainly can do that. Yes.
Couple questions. So is this essentially replacing cloud services?
So this is an interesting question. So I'll just try to navigate it very nicely and properly. So, cloud services, we call it PaaS V1. That is here to stay. There are people who've gone into production with it. So it's going to be there for some time. So we expect people to slowly adopt our platform and see. So for a while, we both will coexist. And then I think one of them, like PaaS V1, would slowly be taken off. But it is not going to be immediate where, I need to migrate over right now. So that's not the case.
And you mentioned that it uses IaaS VMs. Does that mean we're still responsible for managing the OS, updating it with patches, so forth and so on?
So upgrading your OS is something which we actually are offering, will be offering. We're thinking of offering a service which actually would be a part of it, where you can turn the OS upgrades on, and then we'll manage and orchestrate it for you. It's something which we're thinking about. So this is a feedback which we got before, because that is a pain in IaaS. Yes, we got this feedback. Yes.
And the last one to go along with the traffic manager question. So is the Service Fabric cluster have like its own public IP
Yes.
that's load balanced with all the nodes? Is that how it works?
Yes, it actually has one. So if I don't know whether you remember, I showed you on the essentials page on the cluster model, there actually is a public endpoint. Yes, it's an FQDN, and yes. And then once the traffic comes in, we know where to take you from there. So load balancing itself is custom, so it's not any of those. It basically is because I showed you the way that your replica can report load. So at that point, certainly it's not round robin.
Is this in preview now?
Yes. Oh, the service itself? Yeah, it is not. It will be in a few months' time. So I don't have a date, but that is the plan.
So, question about the on-premise version. How much of Azure Stack does it require? Is it everything? Like, are there any pieces of Azure Stack that you can throw out, and can you be selective, so to speak?
So the current thinking is that you'll need the Azure Stack for it, but certainly there is a school of thought we're thinking about where maybe you don't need the whole host because we could just be a feature and then just turn it on. So the decision is not made. So it's a good question. We'll take the feedback.
Kind of going along those lines, I was curious with Nano, Docker, ARM, scale set, and all of that stuff coming along. How does this all tie together and relate?
Okay. So you mixed a couple of things together. One, you started off with containers, then you just went into scale sets. Okay, let's just talk about scale sets first because that's easy. So when we do have a preview, which is when we just talked about, that'll be on VM scale sets. So that then you have the flexibility of VM scale set. So you can just say, here's the minimum my cluster needs to run at. It needs to go up. It can go up to 100. So this is something which VM scale sets allows you to do, and that comes for free at that point. Then you talked about containers. So we would support any Windows container. As long as Windows supports it, if it supports the Docker format, yes, we will support it. If it is the Hyper-V container, yes. So whenever that happens, yes. So for us, we're actually even better, right? So we are one of those people we don't really care about the packaging itself. We actually can look into your package and tell you whether it is healthy or not. So we're actually into microservices. So where you package it is, for us, it's basically, it looks like an application to us at this point. So yes, and that's just the isolation requirement that you need.
What's the licensing model, as far as pricing? Is this like for, as part of like the Windows Server, is this going to be just a part of that? So and if it's in Azure, are we paying for just the IaaS VMs?
So this is a good question. So honestly, I don't know the answer. So IaaS VMs, you don't pay for the server license itself. You just pay for the IaaS VM. So I'd expect that to remain the same. In order to get this technology, we do not know that answer. So marketing is working out that they're doing all kinds of studies. So I do not know that answer. Sorry.
So then how would this work with Amazon if you wanted to run this on Amazon, if you had to pay some sort of licensing fee other than the VM cost?
So I need to take that back. That's a good question. I do not know the answer.
All right. Well, you have it on the slide that you're going to support Amazon.
Did I?
Yeah.
Yes. Yeah.
So, I think I understand the part where you guys are going to run this as a service and kind of manage the VM and set up the clusters and things like that. But there's also, like today, you could just give people the directions to set up the cluster themselves on IaaS. And that kind of directions, and let them do whatever they want. They got to manage it. It's not really multi-tenant. You don't care. Here, go set it up yourself. Those are the kind of directions that people are looking for today if they want to take that and put it into Amazon, and run it right now.
So right now, if you look at our SDK license agreement, the license agreement grants you license to run it on local development box. That license agreement does not grant you permission to actually go run it in Amazon. You do not have that license at this point.
But that's coming. So that was the very first slide I think I showed you.
Technology itself does not have any restriction. There's a licensing restriction. Technology does not have any restriction.
All right. Thank you all. I appreciate all the questions. If you have anything else.